Buckle up, everyone, because today we are launching a deep dive into space exploration.
Sounds exciting.
It is. We're going to be using this fascinating source, space exploration, humanity's ultimate frontier. It always gets me thinking, about how much we still don't know.
That's the beauty of it, isn't it? There's always something new to discover.
Absolutely. Like, did you know that all the stuff we can see out there, the stars, galaxies, planets, it only makes up something like 5% of the universe?
Yeah, it's mind-boggling when you think about it. The other 95% is dark matter and dark energy.
Things we're just beginning to grasp.
Exactly. It's like we're peering through a keyhole into this vast, mysterious cosmos.
And yet, even with all that unknown, there's something about space that just draws us in.
It's that age-old human drive to explore, I think. We've always pushed the boundaries here on Earth, crossing oceans, climbing mountains.
Right. It's like this inherent curiosity, wanting to see what's beyond the horizon.
And space is the ultimate horizon, isn't it? It represents the ultimate unknown.
And potentially the answers to some of humanity's biggest questions. Like, are we alone in the universe? Where did it all come from?
Precisely. But of course, getting to space, actually breaking free from Earth's grip, that's no easy feat.
You're telling me? I mean, the sheer power needed to overcome Earth's gravity is incredible.
It really is. Imagine this. To escape Earth's pull, you need to reach a speed that would let you cross New York City in, less than a second.
Whoa. Okay, that puts it into perspective. I've also heard about this thing called the tyranny of the rocket equation.
Ah, yes. That's basically the challenge of fuel. You see, the more fuel you need, the heavier the rocket becomes.
So you need more fuel to lift the extra fuel.
Exactly. It's this kind of a loop that makes it really tough to get those big payloads into space.
So it's not just about strapping on more rockets, huh? There's a whole lot of science and engineering involved.
Oh, absolutely. Take the Saturn V rocket, for example. That thing was taller than the Statue of Liberty. An incredible feat of engineering.
And it got us to the moon. Speaking of which, we've actually learned a lot about our cosmic neighborhood, even in our, relatively short time exploring space.
We have. Who would have thought we'd find frozen water on the moon?
Right. It's like the moon suddenly became a whole lot more interesting.
It did. And that water ice could be crucial for future missions. Imagine using the moon as a base, a refueling station.
It makes you think about all the possibilities. And then there's Mars.
Ah, Mars. Always a hot topic.
It seems like every time we send a probe there, we find more evidence that it might have been habitable at some point.
Yeah. Think about those ancient riverbeds, those signs of flowing water. We've even found organic molecules.
Which are like the building blocks of life.
Exactly. Now, it doesn't definitively prove there was life on Mars, but it's definitely intriguing.
Makes you wonder, what if we find fossilized microbes or even evidence of a past civilization?
That would be a game changer, wouldn't it?
Totally. And even if Mars turns out to be a bust in terms of finding life, there's always Europa.
Oh, Europa. That's a fascinating one.
One of Jupiter's moons, right?
That's right. And scientists think that beneath its icy shell, there's this vast, salty ocean.
Whoa, a hidden ocean.
Potentially even bigger than all the oceans on Earth combined. And where there's water, there's at least the possibility of life.
It's like something out of science fiction, having this potential oasis for life right in our cosmic backyard.
It is pretty amazing.
But exploring space isn't just about searching for aliens, is it? What about what we learn about our own planet in the process?
Oh, that's a crucial point. You see, studying space helps us understand Earth better. For example, satellites are vital for climate change research.
You can track deforestation, melting glaciers, things like that.
Exactly. It's like having this global view of our planet, giving us insights we just wouldn't get from down here.
It's fascinating how looking outwards can help us understand inwards. But let's be honest, space is a dangerous place.
It is.
I mean, we've seen the tragic consequences of accidents like Challenger in Columbia. Do those risks ever make you question the whole endeavor of space exploration?
Of course. Those tragedies are stark reminders of the very real dangers involved. But for me, the potential rewards, the knowledge gained, the advancements we make, they outweigh the risks.
And you know what always strikes me about astronauts? They're not just explorers, they're like pioneers.
Absolutely.
Living and working in space, on the International Space Station, for example, it can't be easy.
Not at all. Imagine dealing with muscle atrophy in zero gravity, bone density loss, radiation exposure.
Not to mention the psychological challenges of being isolated from loved ones for extended periods.
It's a testament to human resilience and ingenuity. And the research they do up there benefits all of us back on Earth.
Oh, yeah. Like those breakthroughs in osteoporosis research, right?
Precisely. Studying bone loss in astronauts has given us valuable insights into the condition.
It's amazing how space exploration can have these unexpected but profound impacts on human health. Okay, so we've talked about the allure of space, the challenges of getting there, the incredible discoveries, but let's get down to it.
Mm.
Why does space exploration really matter? Why should we spend all this time and money on it when we have so many problems here on Earth?
That's a question a lot of people ask, and it's a fair one. But the answer is more complex than it might seem at first.
Go on, I'm all ears.
Well, first, think about all the practical benefits. So many technologies we use every day came about because of space research.
Give me some examples.
GPS navigation, satellite communication, weather forecasting, all of that wouldn't exist without space exploration.
It's like planting a seed and getting a whole orchard in return.
Exactly. And then there's the bigger picture, the existential argument, if you will. Earth, as wonderful as it is, won't last forever.
Right. We've got asteroid threats, natural disasters, not to mention the potential for our own actions to impact the planet's future.
Exactly. So space exploration, in a way, is our insurance policy. By venturing beyond Earth, we're increasing our chances of survival in the long run.
It's like not putting all our eggs in one basket.
Mm.
But it's more than just survival, isn't it? There's something inherently human about wanting to explore, to push the boundaries, to see what's out there.
Couldn't agree more. It's about our curiosity, our drive to understand our place in the universe, and perhaps even discover that we're not alone.
It's a pretty inspiring way to think about it.
Yeah.
And speaking of exploring, where to next? What are the destinations that have scientists and space enthusiasts buzzing?
Well, let's take a look at what the future holds for humanity's journey into the cosmos. Well, the moon is having a moment, wouldn't you say?
It really is. It's gone from a historical achievement to like this frontier for future exploration.
Yeah. It's not just a place we've been, it's a place we might be going back to, more permanently.
Exactly. With programs like Artemis, it feels like we're on the edge of this whole new era of lunar exploration. What's driving that renewed interest? What's changed?
I think a few things. One is, we've discovered that the moon has more resources than we initially thought, like that water ice we talked about earlier.
Right.
That could be a game changer for setting up a sustainable human presence. I mean, think about it. You can break water down into oxygen for breathing and hydrogen for fuel.
So the moon could actually become a refueling station for missions further into space.
Potentially, yeah. It's like a stepping stone to the rest of the cosmos.
That's fascinating.
Yeah.
But what about the challenges? I mean, living on the moon, it's not exactly a walk in the park.
It's not, no. It's a harsh environment. You've got no atmosphere to speak of, so you're exposed to radiation, micrometeoroids.
And temperature swings, right? I imagine those are pretty extreme.
Oh, absolutely. Plus, the gravity is much lower than Earth's, only about 1/6, and that can have long-term effects on the human body.
It sounds like we need some serious tech to make living there viable.
For sure. We're talking advanced habitats that can shield against radiation, maintain a stable environment inside.
What about, like, life support systems? And how would we even build structures on the moon?
Well, that's where things like 3D printing come in. Potentially using lunar materials, to build structures right there on the surface.
It's mind-blowing to think we might have lunar outposts someday.
Yeah.
Maybe even entire cities. It's like science fiction becoming reality.
And who knows, maybe one day your kids will be applying to lunar universities.
No, that's a thought.
Yeah.
But as exciting as the moon is, for many, the ultimate goal is Mars, right?
Oh, yeah. Mars has this hold on the human imagination, doesn't it?
It does. I remember as a kid looking up at Mars and just wondering, is there anyone else out there looking back? And now it seems like actually sending humans to Mars is becoming more and more realistic.
It really does. Space agencies all over the world and even private companies like SpaceX are working towards it.
What are some of the biggest hurdles we'd need to overcome to make a Mars mission successful? Like, what are the real challenges?
Well, for starters, the journey itself is a huge challenge. With current technology, it takes about 6 months to get to Mars. And that's just one way.
6 months. Wow. So you're talking about exposing astronauts to prolonged microgravity, cosmic radiation, and not to mention the psychological stress of being cooped up in a spaceship for that long.
Exactly. It's not going to be easy on them, physically or mentally.
And then once they land, well, the Martian environment itself isn't exactly welcoming, is it?
Not really. It's a cold, dry desert, very thin atmosphere, so not much protection from radiation. Average temperature is about -63 degrees Celsius, and then you have these dust storms that can engulf the entire planet.
Yikes. It sounds pretty harsh.
It is. We'd need to develop habitats that can provide breathable air, regulate temperature, basically create a little bubble of Earth in this incredibly hostile environment.
It sounds like a monumental task. But even with all that, there's this, like, real excitement about going to Mars. Why is that? Why Mars?
I think there are a few reasons. From a scientific standpoint, Mars gives us this unique opportunity to study another planet's history, to look for signs of past or present life.
To try and understand how planets evolve, how they work, basically.
Exactly. But beyond the science, there's also that element of adventure, that drive to push the boundaries of human exploration, to set up a permanent base on another world.
It would be like becoming a multiplanetary species.
Yeah, it would be a huge step for humanity.
So Mars is definitely a contender, but it's not the only intriguing destination out there. We touched on Europa earlier. What other places in our solar system are catching the eyes of scientists?
Oh, the outer solar system is full of fascinating worlds just waiting to be explored. There's Titan, for example.
Titan. Refresh my memory. Which one is that?
It's Saturn's largest moon, and it's the only moon in our solar system with a dense atmosphere.
Okay, interesting.
In fact, the atmosphere is so thick you could theoretically strap on wings and fly there.
Wait, you're serious? We could actually fly on Titan.
Well, it wouldn't be with wings like birds, but the principle is the same. The atmosphere is dense enough to support flight. Of course, you'd need a breathing apparatus because the air is mostly nitrogen with a lot of methane.
Methane, like the gas.
Yep. And it gets so cold on Titan that methane actually rains from the sky, forms lakes and rivers on the surface.
Wow. Methane rain, methane lakes, and the possibility of flying. Titan sounds like something straight out of a sci-fi movie.
It's a pretty wild place. And then there are icy moons like Enceladus, which has these geysers erupting from its south pole, spewing water vapor and ice particles into space.
Geysers. On a moon.
Yep. Scientists think it indicates a subsurface ocean on Enceladus, and that ocean could potentially harbor life.
It's amazing the things we keep finding out there.
It really is. And it all just highlights how diverse and how strange our solar system is. But as fascinating as these places are, they're all still within our own cosmic neighborhood. What if we could go beyond our solar system to other stars and planets?
Now you're talking interstellar travel. That's the stuff of dreams, isn't it? Is that even remotely possible?
It might seem that way, but scientists and engineers are actually working on concepts that could make interstellar travel a reality. One project is called Breakthrough Starshot.
Breakthrough Starshot. What's that?
It aims to send these tiny light-powered probes to Alpha Centauri.
Hold on, Alpha Centauri. That's the closest star system to our own, right?
That's right.
Okay, so how would that even work? Sending probes to another star system.
The idea is to use powerful lasers here on Earth to propel these tiny probes, which would be attached to light sails up to a significant fraction of the speed of light.
So they'd be riding beams of light to another star system.
In essence, yes.
It sounds incredible. But if it did work, what kind of information could those probes gather?
Well, they'd be equipped with cameras and sensors that could capture images and data about the planets orbiting Alpha Centauri.
They could tell us if those planets are habitable, maybe even if there's life there.
Potentially, yes.
That's pretty mind-blowing. Imagine getting a glimpse into another solar system.
It's amazing to think it might be possible in our lifetime.
It really is. But as much as we talk about exploring other planets and searching for life, it all comes back to that one fundamental question, doesn't it? Are we alone?
That's the question that drives a lot of this exploration, I think, that deep-seated human need to know if we're the only ones out there.
It really makes you think, doesn't it?
Yeah.
About our place in the universe, I mean.
It does. It forces us to step back and look at the bigger picture.
Are we just this tiny blip on the cosmic radar? Or do we have some bigger role to play?
It's a humbling thought, for sure.
It is. And as we explore space, it's not just about discovering new worlds. It's about discovering new things about ourselves, too. Don't you think?
I think you're absolutely right. Space exploration is a journey of self-discovery as much as it is about scientific advancement.
It challenges our assumptions, pushes us to our limits. We learn about our capabilities, but also our limitations.
Exactly. And we're constantly reminded that we're part of something much, much bigger than ourselves.
Speaking of bigger things, we talked about some of the ethical considerations of space exploration earlier. As we get better at going further, doing more in space, those ethical questions become even more important, right?
Oh, absolutely. We're writing a new chapter in human history, and we need to make sure it's a chapter that reflects our values, that we're doing things the right way.
So what kind of ethical dilemmas might we face as we go further into space? What are the things we need to be thinking about now?
Well, one big one is planetary protection.
Mhm.
We have to be incredibly careful not to contaminate other worlds with Earth-based life.
Like, imagine if we discovered microbes on Mars, only to find out later that we brought them there ourselves.
Exactly. That would be a disaster for science, not to mention a huge ethical violation.
It's like that saying, take only pictures, leave only footprints, but on a cosmic scale. We have to respect those pristine environments.
We do. And then there's the issue of resource extraction. If we set up a base on the moon on Mars, we're going to want to use the resources there.
Sure.
But how do we do that sustainably? And who owns those resources?
But right, who has the right to those resources? Those are some big questions.
They are. We're going to need a set of guidelines, some kind of cosmic rulebook, to figure out how we interact with space and with each other out there.
A framework for responsible and ethical space exploration.
Exactly. It's not just about exploring, it's about doing it the right way, for ourselves and for future generations.
And it's worth remembering that space is still dangerous.
It is, very much so.
We can't forget the lessons of Challenger and Columbia. As we push the boundaries, safety can never be an afterthought.
Absolutely. It has to be the top priority. We need to learn from our mistakes, constantly assess and mitigate risks. The well-being of the astronauts, the integrity of the missions, those have to come first.
And it's not just the physical risks either, right? We have to think about the psychological challenges of long-duration space travel.
Oh, for sure. That's a crucial area of research, especially as we look at missions to Mars and beyond. Prolonged isolation, confinement, radiation exposure, all of those things can have a huge impact on mental and emotional health.
It's easy to, simulate those conditions here on Earth, but actually experiencing them out there in the depths of space, that's a whole different ballgame.
It is. We have to figure out how to support the astronauts, how to help them stay healthy, both physically and mentally, on these long-duration missions. And we have to think about the social dynamics, too.
Oh, right. Like, how do you create a crew that can function effectively under extreme pressure? A crew that can work together, that can support each other, even when things get tough.
Right. Those are things psychologists and social scientists are working on, trying to figure out how to build those resilient teams. It's fascinating stuff.
It's not just about rockets and spaceships. It's about people. And I know some people criticize space exploration, saying it's a waste of money, that we should focus on solving problems here on Earth first. How do you respond to that?
Well, it's understandable that people are concerned about the cost, especially when we face so many challenges here at home. But I think space exploration is an investment in our future.
In what way?
The technologies we develop for space often end up having applications back here on Earth.
Give me an example.
Sure. Think about advancements in medicine, energy production, communication, even things like material science. A lot of those breakthroughs came about because of space exploration.
It's like those ripples spreading outward, having an impact far beyond the initial investment.
Precisely. And then there's the inspiration, the way space exploration captures our imaginations. It encourages young people to pursue science and engineering, reminds us of what we can achieve when we work together.
It's something that brings people together, something to be proud of.
Absolutely. It's a reminder that we're all part of this amazing journey on Spaceship Earth.
I love that Spaceship Earth. So well said.
It's been a pleasure talking about all this with you.
Same here. And to our listeners, thank you for joining us on this deep dive into space exploration. We hope you learned something new and maybe even feel inspired to keep looking up at the stars and dreaming big. Until next time, keep exploring.